The FAME project aims to unlock the full potential of the data economy. By developing a secure, federated, decentralized, and energy-efficient data marketplace, FAME enables the trading and integration of data assets, including datasets, AI and ML models, and more across interconnected data providers. This tutorial explains how to use the Situation-Aware Explainability for Business Processes library, which aims to provide sound and interpretable explanations of outcomes and decisions in business processes. FAME has developed a federated, decentralized data marketplace for embedded finance that integrates data assets from multiple providers, enabling efficient and secure trading and monetization. FAME uses innovative technologies such as explainable AI and situation-aware explainability to provide transparency and build trust. In this tutorial, we present the SAX4BPM tool, developed in the project and released as an open-source Python library. SAX4BPM is a novel tool that provides an easy and intuitive way to generate explanations about business processes. These explanations are uniquely synthesized by blending multiple knowledge perspectives about the process, with a particular focus on the causal dependencies between the activities. There are two main ways to use the library. For core process analysis, you can use the pip install command in your own IDE and run the core services for process and causal discovery. The library lets you import process event logs in standard formats such as XCS and CSV, and then invoke the discovery functionalities. A second way to use the library is interactively. A simple Streamlit user interface lets you type in queries about a process and have the system synthesize explanations that are informed by different knowledge ingredients about that process. Let's start by reviewing how may one install and run the core services using the pip install approach. Let's go first to the SAX4BPM library on GitHub. We'll do a quick Google search to find it. Here it is. You can also access it directly at github.com/IBM/SAX4BPM. On the main GitHub page, you'll find all the related library files, along with links to introductory materials that will help you get started quickly. For example, one quick way to get started is by using the pip install command. This allows you, as a developer, to easily access the core library services directly from your own Python code. To do that, let's first set up a new Python project in Visual Studio Code. We'll set up a new notebook project with a Python runtime so we can easily follow the initial steps. The first command we'll run is !pip install SAX4BPM. This will result in downloading all the relevant library files and dependencies into your project. Give it a few seconds to complete. Next, we'll add all the required library imports. These will load the tools you need for data import, data formatting, process mining, and causal process discovery, as well as formatters that let you read and write event log files. We'll also load shared constants that standardize things like column names and a utility that draws the causal graphs as diagrams. Next, we'll copy a demo event log file into our project so we can examine it. we'll place the corresponding CSV file into our project folder. Now we'll load an event log CSV file to explore. We then call the SAX wrapper for process mining to read that CSV into an internal event log object. We tell it not to perform special K-loop unrolling on repeated activities in traces, and to interpret the timestamp column using the exact date and time format specified. Let's now read from the file to verify that it was loaded correctly. We can now further examine the mandatory and optional properties in the file. Using the function getMandatoryProperties, we can see how SAX maps the standard event log fields to your actual column names, and with the function getOptionalProperties, you can inspect extra columns that are not required by the log format but were found and recognized. For example, case::concept::name is mapped to the ID column, which is the case identifier. Similarly, the activity name, event time, type, and timestamp are mapped. Resource and role were recognized as optional, providing additional contextual information about who performed the activity and in what role. Okay, so now let's do some actual analysis of the log. We'll run a simple process mining discovery and then visualize the result. First, we import the process mining module and call the function discoverHeuristicsNet on our event log. This computes a process model from the recorded events. Then we call the viewHeuristicsNet function to render a graphical view of that model, showing the activities as nodes and the control flow relations between them as edges. Last but not least for this part of the demo, we'll run causal process discovery on our event log. First, we import the causal discovery module, and then simply call the discover causal dependencies function with our event log as the input argument. This analyzes the event log and learns the causal execution dependencies between activities. Finally, we call the view causal dependencies function, which renders a diagram that visualizes these discovered causal dependencies as a graph, showing which activities appear to causally influence others. So far, we have demonstrated how the core library services can be used to run discovery functionalities in Python. Next, let's see how may we switch to the interactive mode. A second way to use the SAX4BPM library is to interact with it through its built-in Streamlit user interface, which we also refer to as the eExplainability Studio, or XStudio for short. To do this, you first need to clone the project from GitHub. So, we'll start a fresh Visual Studio Code project for that. Once the repository is cloned, you can see that all the library folders have been fetched locally, including the Streamlit folder that contains the main user interface pages. These are the pages we'll soon interact with to not only examine a process log, but also generate meaningful explanations about it. Let's first complete the setup of the project environment by selecting a Python interpreter. If, as in our case, the Streamlit module has not been installed before, we need to install it in the terminal window by running the command pip install Streamlit. You can't just run the demo file directly from your project environment. To bring up the user interface, you need to start the Streamlit server by running the command streamlit run. This will start the server and open the application in your browser. Once the application has loaded and you move past the initial welcome screen, you'll see a menu on the left-hand side. This menu lets you gradually step through the inspection of a process event log. Oh, just before that, to make sure everything connects to the LLM model of your choice, you also need to set the OpenAI environment variable with your own API key. Do this in your shell using the export command. Let's bring back the Streamlit UI. Next, either drag and drop the CSV file you want to examine or select it from your file system. We'll load the simple log that corresponds to our demo email archiving process. Once the log is loaded, we can fine-tune how its attributes are mapped to your actual column names to ensure proper parsing of the log. For example, case::concept::name is mapped to the ID column, which is the case identifier. In a similar way, we adjust the mappings for the activity name, the event time, and the timestamp format. You can also specify whether the log contains a start timestamp and lifecycle columns. But for this demo, we'll keep the default settings and click the Perform Analysis button to invoke the mining algorithms. Once the command is invoked, we can see that the CSV file was parsed successfully, and its contents are displayed in a tabular format. Next, we can switch to the process view to see what the process model corresponding to the events in the log looks like and which variants were discovered. In this example, there is only a single execution sequence in the log. The analysis view shows, side by side, both the process model and the causal process model that were discovered. In the causal model, the arrows connect activities that actually cause the execution of the activities they point to, rather than just indicating that one activity usually happens after another. With both models rendered, you can now switch to the interactive XStudio query pane, where you can type questions about the process and choose which models should be considered when answering. For example, let's ask, what may cause delays with application loading? First, we tick only the process model, and the answer we get relates purely to the temporal aspect of the process. Next, we also tick the causal process model and submit the same query again. This time, we receive a more insightful answer, one that also takes into account the causal relationships between the activities in our process. This gives you a convenient yet powerful way to gain deeper insights into the process. You can also tick the XAI option to render feature importances and enable the content view, which lets you upload additional documents, such as content from process manuals, to be rendered as well. Curious to see if our tools fit your organization? Try them out yourselves. They're free, user-friendly, and ready to use. Visit our website to access all the documentation and training materials you need. And remember, we're here to support you every step of the way.